Good. Right. Yeah. So this is a bit confusing, right? A to the 2 divided by A to the 3 divided by A to the 4 and so on. It's a bit confusing to know what are dividing by. All right. Especially when I have a multiplied by A to the power 6 inside of here, and I start incorporating a set of other operations. So instead of representing division by putting we line, we represent division using we normal divided by A to the 2 divided by A to the 3 divided by A to the 4 and so on, divided by so on. Well, the law state that I had a minus the powers. 1 minus 2 minus 3 minus 4 minus going on the root. Yeah? Law 3. Who could remember what law 3 is?
If we have a base raised to multiple powers, we multiply the powers.
Very good. If we have a base raised to multiple powers, we multiply the powers. Now, it doesn't matter what the base is. The base could be 16.2. It doesn't matter. Once I have a base, that is my base, and the base is raised to multiple powers, 2 to the power 3. And then that is raised to the power 4. And then that is raised to the power 5. The law says I have to multiply the powers. So this is 2 to the power 3 by 4 by 5, whatever I get. Right? Whatever I get there, I get. Law 3, it's easy to see and easy to execute. It'll have no trick, it'll have no hint to using law 3. Multiply the powers, right? Easy. The only difficult thing you'll encounter with law 3 is if you have something like this. A to the power of 2 raised to the power x plus 1. And I'm going to say this from now. If you have more than one term on a power, meaning x plus 1, that is more than one term. In the previous example, 2 to the power 3, my power is 3, then I have another power of 4, then I have another power of 5. But in the second example here, I have a to the power 2. 2 is one term, raised to the power x plus 1. X plus 1 is 2 terms on a power. When I have 2 terms on a power, put that power in a bracket. So bracket of the power, bam, bam. And the law says when I have a base raised to multiple powers, multiply the powers. 2 into x plus 1. And I should be able to distribute this as a to the 2x plus 2. Yeah? Law 4, simple, easiest law you'll ever encounter in your life. What is law 4?
If we have a base raised to the power 0, the value is 1.
Very good. Any base raised to the power 0 has a value of 1. For example, 4 to the power 0 is 1. X to the power 0 is 1. As long as the power on any base is 0, the value is 1. And I like to use this one. Desk to the power 0. Desk is the base. raised to the power 0 that has a value of 1. Yeah? All right, law 5. Who could remember what law 5 is? Off the top of the head.
So if you have a product or a quotient raised to a power, each term must be raised to that power.
Very good. If we have a product or quotient raised to a power, each term must be raised to that power. For example, xy to the power of 2. What operation is affiliated with product?
Multiplication,
What operation is affiliated with quotient?
division,
Very good. So xy squared, that's a product, xy. Yeah? It's raised to the power of 2. So each term must be raised to that power. Same thing for quotients. X over y raised to the power of 6. X to the 6 over y to the 6. Sometimes we have both product and a quotient in an indice question. 2x over y a raised to the power of 3. Everything must be raised to that power. 2 cubed x cubed over y cubed a cubed. Yeah? Make sense? And again, all this should be some sort of revision for you guys, right? For most of you guys at least, because we did this in school. Law 6, Miss earlier.
So if you have a base raised to a negative power, you must flip that base and change the sign of the power to positive.
Very good. Now, law 6 is a little sensitive one. And the reason I make up this definition is because it's easy to follow the definition and then see the reverse of it. All right. So if we have a base raised to a negative power, we must flip that base and change the power to positive. Yeah. For example, if I have a base, say the base is 2, raised to a negative power, minus 3. The first thing I want you guys to do, identify which base has the negative power attached to it. In this case, 2 has the negative power attached to it. Let's see who is this. All right. Because you're late.
Yeah, sorry, sir. I thought it was 8:30.
I know what thought make a man do. All right, Krish. Remind me what school you're going to.
One sec.
All right. All right, cool. No see. Your parents will talk to me, right?
Alright.
Huh?
I said alright.
No, I'm asking you.
Oh, I think she's supposed to call, yeah?
All right, that's more thing. All right. Important thing is you're here. Cool.
Yes. Sir.
All right. So continuing, you go get a recording of everything, right, Krish? Don't fight up yourself. Just follow it, man, as best as you could.
Alright,
Um, so first things first, we identify which base has this negative power attached to it. In this case, the base that has the negative power attached to it is 2. Yeah? So the law says we must flip that base. Now, when I'm flipping something, some of you all would like to use some fancy terms. So is the reciprocal, is the inverse. All I want all to do when you're flipping something, if I flip in a numerator, it becomes a denominator. If I flip in a denominator, it becomes a numerator. That's all I want all to do. So in this case here, 2 is a numerator. So when I flip it, 2 will become the denominator. Yeah? So this becomes here 1 over 2 to the power of 3, because the law says I have to change the power to positive. Now, some of you go ask, well, so where did 1 come out from? Yeah? Where did 1 come out from? Generally, when I have a number, and that number, any number, 2, 3, 4, 5, any number, we have some operations involved on this number that we don't write, that we don't see. One of the operations is a multiplication. Right now, as we speak, 2 is being multiplied by 1. Sorry. 2 is being multiplied by 1. But we don't write it. Right now, as we speak, 2 is being divided by 1. Again, we don't write it. Right now, as we speak, 2 is raised to the power of 1. But again, we don't write it because these operations here are understood. So if I were to extend on my first example here to figure out, well, so where that come from? Where's that? 2 to the minus 3, if I were to include the invisible operations, bam, bam. Yeah? I could agree on that. These are operations, they exist there, but we don't write it down. Now, first thing I tell earlier, identify which base has the negative power attached to it. Is just the 2. So the only thing I am moving is the 2. And when I flip something, I said, brother man, just if it's a numerator, make it a denominator and vice versa. So the only thing I'm interfering with here is 2. The 1 remaining on top, that multiplied by 1 remaining on top, the 1 remaining below. I just move in the 2. Multiplied by 2 to the power of 3. That's all I do. But like I said, I don't need this 1 multiplied by 2 over there. 2 to the power of 3. The 1 on top is important, however. It is important. All right? And you all will see it a little better in the next example. A, B to the minus 4 over C. What am I moving? I'm moving the only thing with a negative power attached to it. What has the negative power attached to it?
B.
B. A, what power is on A?
1.
What power is on C?
1.
Again, this have a 1 here and this have a 1 here. It's just, we don't write it in because it's understood. So the A remaining there, the C remaining there, and the only thing that moves is the B to the power -4, and it becomes B to the power 4. Yeah? Now, if you have any questions, feel free to ask it.
Excuse, sir.
Yeah.
Just want to make sure I understand, right? So let me say the AB was in brackets, then the whole AB would go at the bottom, right?
Yes. Because when you have a bracket, and let me do an example like that then. If I have, instead of AB, I use an xy to the -3 over 2. Right now, the whole base is xy. Yeah? If you wanted to be fancy, you could have used law 5, then use law 6. Because xy, brother man, is a product. Yeah? And law 5 says if I have a product or a quotient raised to a power, each term must be raised to that power. So I'm breaking it down a little bit here. This is x to the -3, y to the -3 over 2. Brother man, both terms have a negative power attached to it. So both terms need to move. The x need to move and the y needs to move. Now remember, we have the imaginary multiplied by 1 on top here. Okay? So this becomes 1 all over because everything moves from the numerator. Everything, leaving 1 alone on top. The 2 he don't need to move. The x moved to the below and the power became positive. The y moved below and the power became positive. Yeah? You guys seeing that? Anybody confused about that so far? Krishna, I expect it to be a little confused, but when you watch back the video and you're still confused, then you go talk to me. Cool?
Yes, sir.
All right, see. All right. You see how the law worked from a negative power down to a positive power? The reverse works as well. So if I were to redefine law 6, I will say if we have a base and we are moving the base from numerator to denominator or vice versa. So I will illustrate as I write. If we have a base A over B squared cubed, and I am moving the bases from numerator to denominator or vice versa, I must change the sign on the power. I'm going to put this as a to the -2. I must change the signs on the power. Let me extend this here, right? 2a to the -2 over 4b cubed. Let me say I move the b cubed and I bring it on top. Let me put 7 here. I move the b cube and I put it on top. This becomes 2a to the -2, b to the -3. As long as I move a term from numerator to denominator or denominator to numerator, change the sign on the power. All over 7. If I want, and I move the a below, the power on the a must change over 7a squared. If I want to move the 7 on top, 2b to the -3, 7 to the -1 over a to the power 2. If I wanted to move the 2 below, b to the minus 3, 7 to the minus 1 over 2 to the minus 1 a squared. You all following with me? So law 6 has a lot of versatility inside of it. And I want you all to really be comfortable using law 6 because it's so important coming on to the end of admaths. So important. All right, you need to be versed in law 6. And lastly, law 7 states, if we have a base raised to a fractional power, the denominator on the power gives the root of the base. Now, law 7 is a long worded one, right? Don't be frightened. And the numerator gives the power on the root. All right, so give me a second. I had to go on my bird now to want to go back in the cage. So take this down in the meantime. I'll be back in about a minute. Right, fellas. Pause for the cause. Let's continue. All right, so law 7. If we have a base raised to a fractional power, the denominator on the power will give us the root, and the numerator gives us the power on the root. It could be on or inside the root, right? On or inside the root. So let me try it. For example, 4 to the power of 2 over 3. First thing you should ask yourself, or first thing you should notice, brother man, fractional power. You all seen that? Or look at identify this power is indeed a fraction. Yeah? The law says that the denominator tells us the root. So the denominator is 3. So just a little side note on the side here. We have that. We have that. We have that. We have that. And so on. All right. Now, some of you are familiar with it already. And all you know the answer. So shut up. Don't answer. All right. Now, the first one, just like how we had the case where we had the number and these operations are understood, there's a root where an operation is understood, and that's square root. Yeah. So square root, you could either put a 2 on the outside here, or you could leave it out. Once I see this root sign here, I know, well, is the square root I'm looking for. Yeah. So Krish, I directing this question at you. You could confirm that this is indeed square root. Yeah.
Yes, sir.
What will be the next one? With a 3.
Cube root, sir.
Nice. I like where it's going. What about the next one? Pressure. Chatting
Yeah.
now. Chatting. What word you gonna put?
Sir, you don't know.
Chatting na man. Try a thing. I don't care if you get wrong. Chatting. I could bet you, yeah, going and forget it after today. But I had a chatting for my first.
Just rectangle root, sir.
Rectangle, all right? Because a rectangle have 4 sides, yeah?
Yes, sir.
Hey, what about the next one?
Uh,
Must be 1 9. What is 5 sides, boy? A hexaroot. And
I would think it's like a pentagon, sir.
a pentaroot,
Yeah, probably.
probably. Making sense so far. But if that's the case, then cube root could be tri-root or triangular root. Yeah?
Yes. Sir.
If we're using shapes to define the name of the root. 2 could be what, boy? How 2 could be square, boy? Square don't have 2 sides. What shape have 2 sides? You know, a letter. V. And a shape. All right, so watch. Easy. This is called the fourth root. This is called the fifth root. This is called the sixth root. And so on. Yeah? So what could be the
Yes.
next one? Krish,
7th root,
seventh root. And the next one,
8th root.
eighth root, and so on. Okay?
Yes.
So the only roots that really have a special name is cube and square. Okay? So once I see a fraction on a base, I know I'm dealing with some form of a root. So one time I go write down a root sign. And then I'll start to figure out, well, where does what go? Based on the definition, 3 will be the type of root. 2 will be the power inside or outside of the root. Now the base will always go inside here, always. The power could either go here or the power could go here. Either or. What I like to recommend, put your power here. Put your power inside of it. All right? Let me do our next one. A to the power 7/11. I know it's a fraction, so I know I'm dealing with some kind of root business. Yeah? Some kind of root business I'm dealing with. The base will always go inside of here. What number going outside the root, Krish?
11, sir.
11. And which part you put in the 7?
In like at A, or you can put brackets and put it outside the brackets.
Very good. But like I said, I always recommend putting it inside of the root sign, close to the base. All right?
Yes, sir.
Now, you will end up in a case where you have something like this. 2 to the power minus 3/4. It will be like, huh, a negative. Negative power, negative root. What's going on here? So let me open it, all the eyes a little bit here. If I have a fraction and I have a negative on that fraction, one of 3 things could happen. One, I can put the negative sign here if I wanted to. This is correct. 2, I can put the negative sign here. That is also correct. Or 3, I can put the negative sign in front of the entire fraction, which is also correct. Now, if I use these 3 variations on the same question here, this could be 2 to the power minus 3/4, or it could be 2 to the power 3/-4. You're going to ask yourself, boy, I'm going to get a whole set of different answers. This could be, well, first of all, it's a fraction. So, all right, the fraction is a fraction on the power. 2 going inside of here. I know 4 had to go outside and 3 had to go here. And then you go put a minus in front of the whole thing. I see it happen. I'm just giving you all variations of what I get in my lifetime. Next man go say, well, you know, again is a fraction. So by so, then brother, the minus on the 3 and the 4 going outside here. And the next man go say, well, it's the same case, 2 to the power 3 and then minus 4 going outside here. What the hell is negative 4th root? What is that? What is that? Madness. So whenever you see a negative power, and the negative power is affiliated with a fraction, use law 6. Then fix and mix. It is always better to work with positive fractions when you have it as a power. All right? Positive fractions on a power, much easier to work with. So instead of having 2 to the minus 3/4 or 2 to the minus 3/4 or 2 to the 3 odd minus 4, all of these three variations you see on the screen here have one meaning. The fraction is a negative. So it don't matter which variation you use, all variations will result in 1 over 2 to the power positive 3/4. 1 over, now I have the power on the fraction. Sorry, the fraction as a power. The 4 is the root. And the 3 is the power inside the root. Tell me what let's see in that. Tell me. All right. Now, this is what I want to do now. I want to take this down in the meantime. Everybody have my number? Well, Brandon, Kedan, Tristan, Mikhail, Aidan, Justin, you have my number?
Yes, I have it.
And Krish?
No, sir, but I'll save it.
All right. Take it down one time because I'll want you to WhatsApp me because I'm gonna make the group now for everybody. All right. I'm gonna write it down on the board. So WhatsApp me. 7934754. Let me make the group one time. All right, so actually everybody just shoot my message so I could send everybody an invite one time and instead of sending it on the group. Just message my name. All right, everybody who here right now, shoot my message on WhatsApp. Quick as you would. All right, so Kedan inside. Aidan inside. Mikhail inside. Rhonda inside. Right, Justin inside. Who's our last one? That's you, Krish? 298-3444.
Yes, yes, sir.
Cool. So that is 1, 2, 3, 4, 5, 6. 6 of us here, right? No. Tristan, you had a message, man. Cool. Everybody inside. Right, so all on your group there, take down these notes. We're gonna do our exercise after this. And couple exercises as well. All right, like I said, the first 2-3 classes are going to be quite repetitive for most of you guys, but it is worth it. All right, it is worth it. If at any point in time you're confused on what's going on and you're afraid to say, in the chat, it has the private option. You could just message me privately in the Zoom chat and I will I'll respond. So big up. Tell me when to scroll down. Everybody good so far? Cool. Everybody on right there? Anybody still writing? All right, so we're good to go, right? Nice. All right, so let me put some of the laws to work now. So we go jump across Galil worksheet. Yeah, man, I can work with this worksheet. Now, a little tip I'll give you guys here. Whenever you see a law, use it. Now, in all of the laws we did above, it looked nice. The bases were there. It was easy to see that the bases were the same to execute the laws. But in these couple examples here, not looking that nice. I'm not seeing any bases that are the same next to each other. Over here, these bases were literally next to each other. 2 to the power 6 by 2 to the power 10. The bases were next to each other, and they were separated by a multiplication sign. Over here, this xy, it wasn't separated by a multiplication sign, but we know that this is a multiplication process. Yeah? We know it's a multiplication process. 2x is also a multiplication process. I don't have to go and put the multiplication sign in between there again because it's understood. Hello, it Mary. Now, in the worksheet, it follows those same rules. You see this dot? This little dot here? In AddMaths, you'll see that dot appearing a lot. That's not a decimal point. That's a multiplication. All right? In AddMaths, a dot represents a multiplication. So if I have x dotted with y, that's a multiplication. All right? It is different from x point y. The position of the dot is different. If the dot is more on the below, it's a decimal point. If the dot is in the middle, it's a multiplication. Okay? So number 13, 7v cubed multiplied by 10u cubed v5 multiplied by 8uv cubed. Multiplication is commutative. Does everybody know what commutative means? If you don't know what it means, you gotta say it. It had no shame, and I only know this from now. It had no shame in not knowing something. It had plenty things I don't know. And when I don't know something, it might be real easy for somebody else. And they could be like, well, how he don't know that, boy? But honestly, me a business. I do business momenting. Man could think I stupid. Me a business. If I don't know something, I don't know it. I want to know it. And the only way I could know it is if I ask. All right? So I go ask again. Anybody don't know what commutative mean? All right, good. So since multiplication is commutative, I can rewrite number 13 in a smart way. So number 13, I'll do it on top here. I rewrite in number 13 in such a way that I put in all the similar bases next to each other. And this is multiplication. An easy thing to do is multiply your numbers. Anytime you have multiplication and you see numbers involved, so there, multiply your numbers. All right. Everybody know how to multiply their numbers here. Is nothing hidden, is no trick, just multiply your numbers. So number 13, I'll multiply my numbers 7 by 10 by 8. As big as a man is, I always resort to my calculator. I have zero shame in doing that. Because 7 by 10 by 8, I want to be sure. I want to make sure. That's 560. Now I'm going to group my terms. I've seen a v cube. All right. I've seen a v5. I've seen an x v cube. I've seen a u cube. And then I've seen a u. Yeah? Everybody comfortable with that? Which law will I use now?
Law 1.
Law 1. So I'll use law 1 for the v's and I'll use law 1 for the u's. Now, we established this power here is 1 on the second u. Yeah? That u has a power of 1. So this is equal to 560. I recommend this. I recommend you write out the addition process. V to the power 3 plus 5 plus 3. U to the power 3 plus 1. Yes, you're smart. But although you're smart, mistakes just happen. Then you add them. 3 and 5 is 8. 8 and 3 is 11. 3 and 1 is 4. Yeah? Easy peasy. Lemon squeezy. Same thing I'll do with number 14. I'll go multiply my numbers. And then I'll go group the same bases together. X to the 1, x to the 5, y squared, y squared. Then I add them. 81, x to the 1 plus 5, y to the 2 plus 2. 81, x to the 6, y to the power of 4. Easy? All right, I want all to do 15 and 16. Put the answers in the chat and we're moving on to our next worksheet. Big up. 15 and 16 are doing for me now, and the rest are doing for me for homework. All right, we're doing more worksheets. We're rattling off worksheets for the rest of this class today. Big up. Group multiplier numbers, group the bases, put the same bases next to each other, add the powers. Let me get the next one in the meantime. Right, them things should be lick up thing, eh? All right. Remember, wait in the chat, eh? In the Zoom chat. Cool, cool, cool. Love to see it. All right, so I'm looking up the dance. Number 15 is 48, M5 and 6. And number 16 is 36, X5, Y4. All right. Give me number 11 and 12 answers. Quick as you would. Same thing, except now is division. And division is taking away the powers instead of adding the powers. Same thing with the numbers, divide the numbers. Don't give me no decimals, huh? Now, the way you're writing the answers, so for number 12, you need to be specific, okay? Very, very specific. All right, so I see null again, number 11, correct? 2n to the power 2 divided by n. This is n to the power 1. That is 2n to the 2 minus 1, which is 2n to the power 1. And you can leave it as 2n if you wish. Number 12, 8x cubed over 10x to the power 5. You can simplify the fraction. This becomes 4 over 5. X to the power 3 take away 5. 4 over 5 x to the power minus 2. You could leave it like this, or I know that all there's a law involving negative powers. The only thing that has a negative power attached to it here is the x. So I'll move the x to the denominator and change the power to positive. 4 over 5 x to the power of 2. The 4 don't have to move, the 5 don't have to move because those have positive powers attached to it. Generally, either one of these answers, you will get it correct. But generally, as an AdMath student, I personally will require you guys to express all answers as positive powers. All right? I don't want to see no negative powers. I want to see positive powers, and it will give you a little practice using the powers. 13 and 14, go. Ah, Tristan, be careful, Tristan. Watch back number 13, good. Watch your answer and watch number 13 real good. Mikhail, I could simplify number 14 still. Oh, no, never mind. I'm now seeing 14 is 14 dot. You seen it, Mr. Tristan? Cool. Fix it. All right, so number 13. In order to use the laws, law 1 and 2, the bases have to be the same. It have no bases that are the same in number 13. But I can simplify the fraction. This fraction turns out to be 4/3. X cube, I have nothing to do with the x cube. And the y to the 8, I have nothing to do with the y to the 8. So the only thing I could simplify in number 13 is the fraction itself, because I have no same bases. Number 14, however, I do have same bases. I could simplify the fraction. 14/6, that is 7/3. And I have x to the power 4 take away 5, y to the power 7 take away 4, which is 7/3, x to the minus 1, y cubed. The only thing I want to move here is the x. That's the only thing that has a negative power attached to it. So this is 7/3. The y cube remains on top, and the x to the power 1, while the x to the minus 1 goes below, and the power changes to positive. Everybody comfortable with that? All right. So this is what I want all you to do for me now. For homework, I'm going to send across everything here on the group now. For homework, I want all you to finish out the rest of questions over here, 17 to 26. Finish it off, right? And finish off the rest over here from number 15 to 20. In the next class, we are going to explore bases that are not the same, see how we deal with them. That should take us the first half of next class. Then we are going into simplifying exponential equations and solving exponential equations. All of these things here are exponential expressions. All right. An exponent is something raised to a power. As soon as you see a power, the power is an exponent, or the power is a power, or it's an index. All right. Now, each of these terms, each of these questions here are referred to as exponential. An equation has an equal sign, an expression does not have an equal sign. So all of these questions we are dealing with right now is exponential expressions. Next class, we are going to deal with exponential equations. Okay? So finish out these things for me for homework. Take down the rest of your notes when I send it across on the group. I'm seeing you guys next week, Monday, same time, same place. I will also send the link for the class on the group once it's uploaded. All right. All right, guys. So if you all have any questions, feel free to ask. If not, you all can go ahead and leave, and I can see you guys next week.
Later, sir.
Later.
Bye, sir.
Laters.
Bye, sir.
Yeah, later. Make sure and do all your homework, guys.